What if a black hole was not a bottomless hole in space at all, but a 4-layer solid object squeezed to the edge of breaking? In the energy filament theory, a black hole is not an empty pit but a piece of the energy sea pulled so tight that it behaves like a solid cosmic core with 4 working layers that share the load. You can picture it less like a drain in the bathtub and more like a cosmic egg crushed in a giant hand. The outer shell is the pore skin, the thing textbooks call the event horizon. In this picture, it is not a thin mathematical surface. It is a paper-thin, ultra-tense boundary where the energy sea is stretched to its last safe configuration and never quite still. Under that stress, it behaves like the lid of a screaming pressure cooker. Tiny pores flicker open and shut all over it, letting out tiny spurts of tension and closing again almost instantly, like microscopic safety valves. From far away, all that frantic action averages out into the simple dark ring we draw in diagrams. But up close it is busy, trembling and full of short-lived textures. Just beneath that skin lies the second layer, the piston layer, which is the muscle of the black hole. In falling gas, dust and fields crashed into it from above. The core stews below pushes outward from inside. The piston layer spends its life in a slow, powerful breathing cycle, squeezing in and relaxing out. When the piston mostly holds and only adjusts gently, the black hole feeds in a steady, quiet way and looks like a dark, patient eater. When the piston jerks hard in or out, the same object can flare, flash and even launch narrow jets that punch far into surrounding space. One layer down from the piston you run into the third layer, the shredding belt, which acts like the universe's fiercest blender. This is where matter that has already crossed the outer boundary is no longer just falling. It is being stretched, twisted and pulled apart faster than its internal rhythm can cope. In ordinary conditions, particles keep their identity because their internal cycles run cleanly. They have time to complete their loops and hold their structures together. In the shredding belt, time is so slowed and the tension gradients are so severe that these cycles fall out of sync. Electron orbits, nuclear structures and molecular bonds all lose the ability to finish their rounds before the next wrenching pull hits. Once their internal rhythm collapses, they can no longer behave as stable particles. They unravel into raw energy filaments, thin strands of motion in the energy sea that can be remixed into whatever the core demands. At the very center, instead of an infinitely sharp point, there is the stew core, a cauldron of those filaments at outrageous density. Here the energy sea is not calm for a moment. Filaments are constantly being stretched, cut, knotted, snapped and reconnected. Imagine the thickest soup you could, boiling so hard that it flips its own lid. The personality of a black hole, its flickers, bursts, and the power of its jets is, in this view, largely the way this stewed core slams against the piston layer above and occasionally punches through. When you put these 4 layers together, a very different image appears. A black hole is not empty or hollow. It is too full. It is not deep because there is nothing there. It is deep because the energy sea has been pulled into a multi-stage tension machine where every layer has a role. The pore skin is where the pressure vents in tiny bursts. The piston layer is where the object breathes and decides whether to swallow quietly or spit violently. The shredding belt is where ordinary matter is stripped of its identity and reduced to filaments. The stew core is where those filaments churn in a permanent storm. In one line, a black hole is a 4-layer tenso engine, skin sprouting pores, muscle breathing, belt dismantling structure, core boiling. In the next episode we'll zoom in on the pore skin itself and ask, why a horizon that keeps leaking through tiny valves is not a flaw, but the very thing that keeps a black hole stable. Tap follow, share it on New Physics, Clear Universe.